Hello. So I wanted to talk about machine learning and the different flavors that it comes in. So machine learning comes in two different main flavors. So you got supervised learning and unsupervised learning. So supervised learning can be thought of where you have a dot here and a goal, and whilst it reaches that goal, it has intervention at each section to work out what it's doing, whether it's right or wrong, depending on what we think, the user. So you can think of these dots as parts where the algorithm was evaluated before it reached its goal. So think of our image classification. If we're trying to get this algorithm to classify distinct animals like cats and dogs, and we go through the first phase, and then we check whether how incorrect it was or how correct it was in classifying those animals, we provide a way of correcting the incorrect, and then we let the program run a bit more, and then we get to the next stage, we correct the incorrect, and so on and so forth. So over time, the incorrect gets smaller and the correct get larger up until the point where it can correctly identify an animal independently. So that's more of a version of supervised learning. Now, unsupervised learning is where you have a goal, or let's say our agent here, as a not as a dot, and we have a goal, and we just specify rewards for if the algorithm gets closer to our goal, then we provide it with a positive reward, let's say in this case positive R. And if it gets further away from that reward, we we give it a negative R. So you can think about this like training an animal or potty training a dog, let's say. If a dog does what you want it to do, you give it praise. You say well done, so on and so forth. If it doesn't, you get annoyed at the dog, and the dog doesn't want to be annoyed. It doesn't want a negative reward. It wants a positive reward. And so over time, hopefully, algorithm gets better and better at reaching the goal, hopefully reaching a point where it achieves the goal itself. So I want to focus more right now on unsupervised learning. Before I get into all the code that I wrote up, I want to talk about the libraries that we're going to use. So there's a library here called Gym. It was built by OpenAI, and it essentially allows you to build a framework to develop these reinforcement algorithms. And on top of that, we're going to use a library called Stable Baselines, which has its own library of algorithms you can use. And we're going to be using a PPO, so that's Proximal Policy Optimization algorithm. And just to give you an example of what the code does, without adding any machine learning concepts to that, I'm just going to run this. Now, this code isn't something I developed myself, it's from what I found in a tutorial online, and I've just kind of condensed it down to make more sense as a high-level overview. So this is Mario Brothers. Um, it's a really old game that you would find on the NES, like a Nintendo game. The idea of the game is to get this little Mario character that's bobbing up and down to the right-hand side to reach the flag. Now, in the current state that this program is, this function generates random numbers, and these numbers correlate to position or key presses. So in that game, you can press up, down, left, right, and this section here that's highlighted tells Python to generate a random key. So this is just to kind of explain or to check whether your program works. Now the actual code that generates what actual machine learning aspect is this bit. Yeah, I'm not going to talk about all the code here, but I'll just give you a rough or a high level overview of what it actually does. So we've got these inputs here. So Gym, Super, Mario Bros, our NES wrapper, so we can actually press key presses in, and our stable baseline. And we're getting the game. We're getting some key presses. We're converting the game um, screen capture, so we're actually catching the the frames of the game. We're then putting that into We're then making that into a sort of list or a stack. We're then passing that into our model. So this is our PPO that I talked about before. We then make a learn function. So the model takes those images in and then learns about what would be the best button to press depending on the pictures it sees. And we then save that model, use that same model, and then show it as a test. This whole part here was quite computational heavy, so I've already done this bit, so I'm just going to comment this out. Let's comment that out as well. It should be quite fast, so you can see here it's not doing a great job. It did the same sort of thing as the other random one, but this is trained up to 900,000 time steps. So it was trained for more than, let's say, random. And the thing about these algorithms is they have to be trained for a really long period of time. So it's advisable if you are going to run this on your own local machine that you leave it overnight and then hopefully check tomorrow or something like that. But the general idea is that this algorithm or algorithms like this can find solutions on their own accord. And so I want to start making a series on this where I talk about different games and trying to apply different algorithms to them and just seeing them play out. So yeah, um, I'll catch you next time. Thanks for staying. Bye bye.